All right, guys, welcome back. We are now on 6.3 and we are going to be starting with page 547. So we are going to be adding and subtracting rational expressions with monomial denominators, meaning the denominator is sort of simple, it's just a monomial. But let us start with practicing with fractions because these are actually rational expressions. So we need to find a common denominator. That's what we need to be doing when we're adding, whether it's just numbers or rational expressions. So in this case, the common denominator for 3 and 4 would be a 12. So let me turn both fractions into new fractions that has a 12 as a denominator. So if I want to turn this denominator 3 into a 12, I multiply it by 4. So multiply the top by 4 also. It gives me an 8. Next, if I want to turn that 4 into the denominator of 12, I multiply it by 3. So multiplying this by 3 gives me a 9. And now I have 17 over 12. Pretty simple. Next, 3/5 minus 9 over 20. When we are subtracting, just like adding, you have to find the common denominator. And for 5 and 20, that would be a 20. Okay? So that means I need to turn this fraction into an equivalent fraction wherein the denominator is 20. And then the 5 was multiplied by 4 to give me a 20. So the top, the 3, must be multiplied by 4, gives me a 12. Okay? The 9 over 20 remains the same because it already has a 20 as a denominator. 12 minus 9 is 3 over 20, and you cannot simplify that any further. This one. Now, some of you might be thinking about, okay, 6 and 9. It's not easy to find a common denominator. Well, some of you might say, oh, I know, it's going to be 36 because 6 goes into 36, 9 goes into 36. Now, something that I learned when I was in school was that instead of wasting my time into thinking about what is the lowest common multiple for these two, especially if you're working with numbers that are not easy to do. Well, in the previous fractions, 5 and 20 were easy because 5 goes into 20, but 6 doesn't go into 9. So what I did when I was young was that I just multiplied the denominators, okay? So I was thinking, okay, make new fractions that would have 6 times 9 as a denominator. So that would be 54. So if I make this 6 into a 54, I multiplied it by 9. That means the top has to be multiplied by 9. If I made that 9 into a 54, that means I multiplied it by 6. So I multiplied the 7 by 6, gives me a 42. Remember, we're subtracting. And that would be negative 33 over 54. Now, my method, though, would sometimes result in a big number. You just have to make sure that you are aware that there just might be common factors, okay, that you can cancel out. Well, 33 is divisible by 3. 54 is divisible by 3. So 33 divided by 3 is 11. 54 divided by 3 is 18. Okay? Now, just for good measure, let's just show another method, okay, which is for those who are looking at just doing the least common multiple. Sure, we can do that. 1 over 6 minus 7 over 9. The least common multiple would be 36. So that means if you do it that way, I will turn the 6 into a 36. That means this one becomes a 6. Now this one, the 9 became a 36 by multiplying by 4. Therefore, the 7 is multiplied by 4 gives me a 28. And that would be negative 22 over 36. And both are even numbers, so you can divide the top and the bottom by 2. Same answer. Okay, next one. We're going to be adding and subtracting rational expressions with monomial numerators. As and this one would be easy. So the numerators are just monomials, like one term. So once again, we need to have a common denominator for these two. Well, there's no other way but to just multiply the two. So a common denominator would be to multiply the 2. 7 times 3x would be 21x. Okay, so both of them, I'm going to give a 21x as a denominator. Now, If I want to make that 7 into a 21x, I multiplied it by 3x, isn't it? So that means the top, I would have to multiply by 3x. All right, we'll simplify that later. Now this 5, okay, or this 3x was turned into 21x by multiplying it by 7. Therefore, the top, the 5 had to be multiplied by 7. Let's simplify. 6x squared plus 35 over 21x. Okay. Now take a look. You just might be thinking, oh, is can I simplify this further? You might think that, oh, 6 can be divided by 3 and 21 can be divided by 3. But then you can only do that if you can factor out a 3 from both terms. All right. What I have seen kids do would be this. Oh, they would cancel this out and then they will say, oh, the final answer is 2x squared plus 35 over 7x. That is wrong. Okay, you cannot do that. Okay, so once again, to be able to cancel out anything from the top, you have to make sure that you are going to be factoring out a number from, or a variable or a number and a variable from both terms, not, oops, not just from one. Okay, so in this case, that is the final answer. What is the non-permissible value? X cannot be equal to 0. Okay, so next, 4 over 5ab minus 3 over 4b squared. So the question is, what would be your uh, least common denominator? Okay, so again, guys, it is really up to you. So me, sometimes it's actually faster to just multiply the two denominators. All right, so meaning I will turn these fractions into new fractions that have the denominator 5ab times 4b squared. That's just, to me, that's just a lot faster. Okay, instead of worrying about what it's going to be. For b squared, I need to multiply the top by 4b squared. Now in the second fraction, originally it only had a 3 over 5 over 4b squared. So if this is all I had, and now the denominator is this, that means the numerator has to be multiplied by 5ab as well. Okay. Let's simplify. 16b squared all over 5ab. Now, if you're thinking, why am I not multiply or simplifying the denominator? Because chances are I will have to cancel out something. So why waste my time? All right. Minus 15ab. All right. Okay. So um, you might be thinking, oh, is there anything we can cancel out? The a's and the b's? No. What is it that you see over here that is a common factor for both terms? It's the b, right? You can factor out the b, giving you 16b minus 15a over 5ab times 4b squared. Now that we have factored out something from the top, that is the time when you can begin to cancel things out. This one can cancel with this. So our final answer is 16b minus 15a over 4 times 5 is 20, ab squared. All right. And what would be the non-permissible values? Well, a and b cannot be 0, as you can see here. Now, once again, this b cannot cancel out with this b squared because this b only appears in the first term in the numerator. If you want to cancel out this b, it has to be factored out from both terms, but then the second term does not have a b. Likewise with the a, you cannot factor cancel out these two a's simply because if you want to cancel out this a here, you have to be able to factor out an a from both terms in the numerator. And a only appears in the second term in the numerator. Okay, so there is your answer.